Okay, so both of these are examples of problems that are probably best handled by doing a least common denominator. So here we've got 6, 2, and 8. What's going to be the least common denominator for those? First of all, do we have to worry about the 2? No, because 2 goes into both 6 and 8. So anything that works for 6 and 8 is going to work for 2. So how about 6 and 8? What's our least common denominator? 24 will work. So we're going to multiply this whole thing by 24. I'm going to write it as 24 over 1. So 24 over 1 times 4x over 6. Then we're going to cross cancel the 24 and the 6. Both divide by 6, give me 1 and 4. 4 times 4x is 16x. 24 over 1, we can't forget the negative here. So I'm going to put that as a negative 24 over 1 times x plus 5 over 2. 2 and negative 24 cross cancel, divide by 2, make this 1, and this is a negative 12 times x plus 5. Well, negative 12 times x is a negative 12x. Negative 12 times 5 is negative 60. That's going to equal 24 over 1 times 6x minus 6 over 8. 24 and 8 cross cancel, they divide by 8, giving me 1 and 3. So 3 times 6x minus 6, 3 times 6x is 18x. 3 times negative 6 is negative 18. Now that we've taken care of parentheses, that's always the first step, is to deal with parentheses. Now that we have done that, well, we've done the multiplication, got rid of the denominators. Now that we've done that, we're going to go ahead and combine what we can combine on each side. On the left side over here, is there anything we can combine? 16x and negative 12x make 4x minus 60. That's it. Nothing to combine there. Anything we can combine on the right side? No. So we combined everything we could on each side. That's always the first thing we do after we've taken care of any parentheses or common denominator stuff. Now, however, there's a variable on each side. X appears on each side. We have to get rid of one of them. The smallest one will be the negative 4x. We're going to subtract 4x. It's positive. We're going to get rid of it by subtracting. So over here, we've got negative 60. 18 minus 4 is 14x minus 18. Excuse me. So now the x only appears once. We've got it down where the x is only there once, the variable is only appearing once. So now we can solve. In other words, we can start taking it apart. So we have to do what first? Add the 18. So this is gone. That leaves us with 14x there. Negative 60 plus 18 is a negative 42. And then we divide by 14. That leaves us with just x there. Negative 42 divided by 14 is negative 3. Did anybody actually get that? Yep. Completely different. Well, you could have made this, 4 6x reduced to 2/3. You could have distributed the minus here to make this a minus 1/2 x minus 5 over 2. Oh, sure. So and so then you can cross multiply and divide. Yep. That works. You can combine the fractions. That definitely works. You could have also made it 3x plus 15 over 2 or over 6 and combined it with the 4x over 6 too. would have been x minus 15 over 6. Most of the group's looking at us like, huh? There's at least 3 people in here looking at us like, you can start speaking English now. This one, loads of fun. We must use a common denominator here. Now, what I would do is this. This is 7 over 2x. I would change the 14.5 to an improper fraction. 14 times 2 is 28, plus 1 is 29 over 2, equals 7 over x, minus 10, 10 over 1, however I want to put it. Common denominator is going to be 2x, because there's an x in the denominator. Yep. And if there's an x in any of them, we've got to have an x in our common denominator. It's the highest power of the variable. It goes in the common denominator. So now we'll multiply that out. 2x over 1 times 7 over 2x. Well, there, the 2x's just cross cancel. That leaves us with 7. 2x over 1 times 29 over 2. Well, the 2's cancel out at least. Leaving us 1 and 1x. 1x times 29 is a positive 29x. And that equals 2x over 1 times 7 over x. The x's cross cancel, so we just got 2 times 7 is 14. And 2x over 1 times, it's a negative 10, so I'm going to put a negative up here, times 10 over 1. Now, the only reason I put the negative up here is if one of them is negative, the answer has to be negative. So I'm just putting that negative up here to know that somewhere I've got to include that negative in my answer. You're going to stop yawning too at some point. Negative 2x times 10 is negative 20x. Now, I'm actually kind of fighting off a sneeze, and for some reason that makes me yawn. I don't know why. Apparently it takes a lot of energy not to sneeze. So then, add 20x, because we've got an x on each side, we've got to get rid of 1. The negative 20 is a smaller one, so we add 20 since it's negative. So this is 7 plus 49x equals 14, and then subtract 7. 49x equals 7, and then divide by 49. X equals 0.142857143 approximately. Questions? Not really. Yeah, we're holding our own. Today, we're going to take a little bit of a step into word problems. Word problems, translating word problems, getting the right equation out of them, I feel is the most difficult task in math. Once you've written the equation, once you get used to solving equations, solving the equation isn't bad once you've created it. But figuring out what that equation, what that formula has to be, like I said, I feel is the toughest task in math. Let's start out with something simple where we actually have a formula. And the formula we're going to look at is perimeter of a rectangle. If we have a rectangle that has a length and a width, the perimeter of a rectangle is given as 2 times the length plus 2 times the width. If I tell you a rectangle, bless you, with perimeter of 142 has a length that is 11 inches longer than the width. And I ask you to find the length and the width. Mathematicians. So you've got a length and you've got a width. It happens when you're doing optimization problems, like if you're doing designs for tanks and stuff like that, where you need to have a certain ratio to length to width and whatever when you're trying to optimize your area for your perimeter and stuff like that. This is just the very basic side of it. It would get much more complicated in a real application. So I've got our width and our length, and our perimeter, of course, 2L plus 2W. But one of those can't stay. We can't have, well, actually, right now we've got 3 variables, but we know P is going to be 142. Yeah, 2L plus 2W. One of those has to go because we cannot have 2 variables in this. There's got to be a relationship given between them, and that relationship that's given is, okay, so how do we write that out? L equals W plus 11. So what that means is right here, where there's an L, we're going to replace that with W plus 11. And now we can solve that rectangle, we can solve that equation. That's what I get for coming to work totally sober on a Friday morning. What do we do first here? Yeah, distribute the 2. So 2 times W is 2W, and 2 times 11 is 22. And we do still have the other 2W over here. And the left side is still 142. And then, yes, we're going to combine everything we can on each side. The 142 doesn't do anything different. 2W and 2W make 4W plus 22. Now we've got the variable down to only one appearance, so we can start to take it apart, start to solve it. Subtract 22. 120 equals 4W. And then divide by 4. 30 equals W. So if W equals 30, are we all done? No, we got to go back and make sure we answer the question. The question said find the length and width. Well, we know W is 30. The length is 30 plus 11. So now we've answered the question. Any questions? What's that? Stunned? The length of a rectangle is 3 times the width. The perimeter is 480 feet. Find L and W. I'll give you a little bit of a hand here. It's going to be a rectangle with a width and a length. And perimeter equals 2 times the length plus 2 times the width. I want you to try this in your notes. I'm going to give you a couple minutes. So we look at this one. We can replace P with what? 480. We can replace L with 3 times the width, 3W. So it's 2 times 3W. And then gotta deal with the parentheses first, right? 2 times 3W, 6W plus, we still got the 2W. And then combine 6W and 2W make 8W. And then divide by 8. 60 equals W. All done? Then what? All right, W equals 60 feet. 3 times 60 feet for the length, 180 feet. Good stuff it is. Frank has 40 feet of wire. He needs 3 pieces, 2 shorter pieces, that are equal, and 1 longer piece that is 3 times the others. If Frank uses all the wire, how long is each? Now here, there is not a formula, not like our perimeter, but it helps us to still chart it out. Now, we don't have a picture to draw necessarily, but we have 2 short pieces, right? Then we've got 1 longer piece. What do we know about the 2 short pieces? They're equal. Okay, so we've got a relationship between the 2 short ones and between the long one and the short ones. So those are 2 are equal. If I call each of those x, if I call one of them x, the other one has to be x because they're equal. And the longer one has to be 3x because it's 3 times, right? Those 3 pieces have to add up to 40 feet. Now remember, I think of that as 1x and 1x, right? So 3x, 1x, 1x make 5x equals 40, and then divide by 5. X equals 8. So that tells me this one's 8 feet. This one's 8 feet. This one is 3 times 8, 24 feet. What do you think? Yeah. Now this next one I'm going to show you is probably the more practical one. The next 2 examples, probably the more practical examples, but also the more difficult examples that I don't necessarily expect you to get to. But we're going to take a look at them. They're mixture problems. In a mixture, you have a base and then you have an active ingredient. The amount of the active ingredient is equal to a concentration, which is a percent of the decimal, times the amount of the base. For example, let's say we have 200 milliliters of a 35% alcohol solution. Otherwise known as rum. The amount of alcohol here would be the active ingredient, is going to be the 35% is a decimal 0.35 times 200 milliliters. So that means you have 70 milliliters of alcohol. Make sense? If we mix 200 milliliters of 35% solution with 400 milliliters of 50% solution, what is the final concentration? So what we have here, the one thing that is constant here is the amount of the active ingredient has to add up. So the amount of alcohol here in the 35% plus the amount of alcohol in the 50% has to equal the total amount, right? Well, the amount of alcohol in the 35% is 0.35 times 200 milliliters. The amount in the 50% is 0.50 times 400 milliliters. Up here, we do not know the concentration, do we? Do we know the volume? Yeah, 200 plus 400, 600 milliliters. If we added 200 milliliters to 600 milliliters, we better get 600. Sorry, if we added 200 milliliters to 400 milliliters, we better get 600 milliliters. short an ounce or two somewhere. So now, this is 70. This is 200. Next, we would add 70 and 200 is 270. And then divide by 600 to get x by itself, which will give us 0.45, right? Actually, it was 0.45. So it's a 45% solution. Unfortunately, very seldom do we just mix random solutions together and try to calculate what the result is. Most of the time, we have a certain result that we want. So let's say we want 47% solution. The question is, how much 41% solution should we mix with 150 milliliters of 50% solution? to create the 47% solution. What are the two solutions we are mixing here? Yeah, 50% and 41%. We want to create 47%. Do we know any amounts here? 150, which goes with 50. We're asked to find the amount of 41%. That'll be our x. What's the amount here is going to be x plus 150. Just like up above, we added these two volumes together to get the total volume. Same here. Just one of them is x. So now 50% times 150, that'll be 0.5 times 150. Plus 41% will be 0.41 times x. Equals 47% is 0.47 times x plus 150. We know how to solve that. We got parentheses. Let's do our parentheses first. What can we do here? That's 75. How about here? That's 0.41x. Anything else we can combine on the left side? No. Over here, 0.47 times x. 0.47x. 0.47 times 150. So 70.5, not 80.5. Now, we've done all of our parentheses in the stuff. But there's a variable on each side, which means make one go away. It's positive 0.41, we're going to subtract 0.41x. So that'll be 75.06x. And then, yeah, now we've just got the x is just there once, so we can start to solve it, take it apart. Subtract 70.5. So 4.5 equals 0.06x. And then divided by 0.06, which makes it 75 equals x. So we would add 75 milliliters of that solution. This would come if you're looking at coolant or lubricant that needs to be mixed at a certain ratio. Antifreeze in a car engine, things like that. I agree. So your little meter says it's okay. Keep draining and adding. But wouldn't it be more efficient if you just drain the right amount the first time and add so you don't have to drain out? Yeah, that worksheet I gave you yesterday, the back side of that worksheet. There's 1 through 25 word problems. We'll let you play with those for the rest of the first hour here. So number 3, I'm glad I started the recording right there. So number 3, if I can get my mouse work here, come on. Reboot it off. Back on. There we go. Number 3, it says separate 256 light fixtures. So that the number of fluorescents will be 20 fewer than twice the number of incandescents. Fluorescence equals 20 fewer, so we're subtracting 20 from something, then twice the number of incandescents. F equals 2i minus 20. The total, F plus I equals 256, but F 2i minus 20 plus I equals 256. Then go from there. I'll let you finish that. Which one do you want to look at next? Distribute $1,000 into 3 parts. So those three parts have to add up to $1,000. So that one part will be 3 times as large as the second. And the third will be as large as the sum of the other two. So I'm going to let this one be x, this one's going to be 3x, right? This one's going to be the sum of the first two, 3x plus x. And those three add up to $1,000. So I've got 3x plus x. Well, first of all, 3x plus x is 4x, right? 3x plus 1x plus 4x is divided by 8. X equals 125 bucks. This is 125, this is 375, and this is 500. What's that? Ending on a high note. You got one right? Okay. Well, next topic. What we're going to start looking at now is data that comes in pairs. In fact, we're going to look at something called an ordered pair. And what an ordered pair is it's a pair of numbers that are linked together in a special way. One thing is, possibly for a patient, if you're looking at the medical field, for a patient that is 180 pounds, they might receive 250 milligrams of medication. That's an ordered pair. You might have, for someone who works 2 hours of overtime, they might receive 5 hours worth of flex time for scheduling. Things like that. You guys are used to dealing with these ordered pairs in a coordinate system. You guys done the XY scale for location and stuff like that. So you guys have already seen this a whole bunch. X is always that horizontal axis, and Y is the vertical when it's laid out. And of course, you guys deal 3 dimensions, so Z would be coming straight at you, right, out of the page. Yeah, well, if you're looking at it, I'm looking at your page laying on the table underneath you, coming straight up at you out of the table. Yeah, it's positive, negative, positive, negative. Quite often, you guys don't have 0 in the center. 0, 0, your origin here. Yours is usually offset because you generally have the corner of a part set at that point, or one corner of the workspace, and the part's usually set up here. It's called the first quadrant. Quadrant 1. So you're dealing with positive coordinates for X and Y at least. And the only one that really goes negative is Z goes negative. You go into the material, positive as you clear the material and stuff like that. Usually you set the top surface of the material as Z equals 0 so that your depth is your negative number and so on. Well, mathematically, there are some things we need to be able to do with these coordinates. And one of them deals with equations that look like this. 2x plus 1 equals 7. How would we solve that? Subtract 1. And then divide by 2, exactly. So 3 equals x, or x equals 3. But there's a very similar equation to this. Looks like that. How do we solve it? Subtract 1. Then divide by 2. 6 equals x. But you notice it took the exact same 2 steps to solve that, didn't it? How about this one? How would you solve it? Subtract 1 and I screwed something up there, but that's okay. Divide by 2. We got different answers for x, but you'll notice in all of them, the steps for solving them were exactly the same. You subtracted 1 first, divided by 2. That's because these equations up here all have the same thing here. I just replaced, I don't know why I put plus there, it should be equals. All the same thing, there's just a different number on the left side. That's what we call a family of equations. And we can represent that family of equations as y equals 2x plus 1, instead of having a number over here on the left side. That represents all of those equations of that form, 2x plus 1. To show all the solutions to those equations, there are infinitely many of them. For every possible value you can pick for y, there's a value for x. Or the other way around, for every possible value you can pick for x, there's a value for y. We could make a table of values, but we can't show all of them. The only way we could possibly show all of them is to use a graph. And the way we'd start out for now making that graph would be to make a table and pick values for x. Now, it is human tendency to do like 0, 1, 2, 3, 4. But we need to know what this looks like all across the graph. So it's better if we pick some negative and some positive, like -2, -1, 0. Those are positive 1 and 2. What the heck? Let's see what happens. Well, when x is -1, y is 2 times, or sorry, when x is -2, y is 2 times x plus 1. What is 2 times -2? -4 plus 1, -3. That gives us a coordinate. X is -2, y is -3. -2, -3 right there, right? You guys okay with locating those coordinates? Have you done enough of that in the shop that you know where they're at? Okay. Well, here I'm saying when x is -1, what's y? Well, y is 2 times x plus 1, so I'm going to put -1 in for x. 2 times -1 plus 1. Well, what is 2 times -1? -2 plus 1? -1. So that gives us the point when x is -1, y is also -1. -1, -1 is right there. X is 0. Y would be 2 times 0 plus 1, which is going to be 1. So when x is 0, y is 1. 0, 1 right there. Bless you. When x is 1, y is 2 times 1 plus 1, which is 3. I feel like the count from Sesame Street is 3. 3 beautiful points on the graph. So it's 1, 3. Right there. Now when x equals 2, it's 2 times 2 plus 1, which is 5. 2, 5. And we notice that makes a line on a graph. So every point on that line is a solution to this equation. If I pick a point right there, I trace it down, let's say that's 1.5. Trace it over, that's going to be 4. When x is 1.5, y is 4. That's a solution. I might find here where x is -0.5, y is 0. That's the solution to that equation. Here, x is -1.5, y is -2. That's the solution to that equation. Every point on that graph. Now, not every graph makes a line. We might have y equals x squared plus 2x minus 3. Now we're going to need to make a table again. And our graph. Let's pick a value. I'm going to try negative 2 for x. Notice I'm not putting in anything else below it because this might take a little space to figure out y. So y is x squared plus 2x minus 3. That's negative 2 squared plus 2 times negative 2 minus 3. Be very careful putting these in a calculator. Negative 2 squared is a positive 4. 2 times negative 2 is a negative 4 minus 3. Well, 4 plus negative 4 is 0, minus 3 is negative 3. So that gives us the point negative 2, negative 3. Right there. What do we want to try next for x? Negative 4, really? Why not? What the heck? It's your life. Negative 4 squared plus 2 times negative 4 minus 3. Negative 4 squared is 16. 2 times negative 4 is negative 8 minus 3. 16 plus negative 8 is 8 minus 3 is 5. Gives us a point negative 3, positive 5. Negative 4. I don't know where the negative 3 came from. Negative 4, positive 5. So there's negative 4. Somewhere in there is that point. Let's try something a little easier like 0. So it's 0 squared plus 2 times 0 minus 3. What is 0 squared? 0 squared is 0 plus 2 times 0 is 0 minus 3 is negative 3. You are correct, sir. So 0, negative 3. That would be right there. My guess is we are not dealing with a line. Now at this point, this is another reason why I didn't just throw a bunch of points up there right away for x. It sometimes helps to get a couple points on the graph and figure out where do I need more information. Well, I kind of need to know what happens between here and here, so that might be x equals negative 3. And I kind of need to know what happens up here where x is like 1 or 2. Let's try x equals 1 first, just because, well, that's an easy one, I hope. So 1 squared plus 2 times 1 minus 3. Well, what is 1 squared? 2 times 1? 2. 1 plus 2 minus 3 is 0. That was kind of an easy one. X is 1, y is 0. So x is 1, y is 0 is a point right there. Let's try x is 2. Back here. X is 2. 2 squared plus 2 times 2 minus 3. 2 squared be 4. 2 times 2 is 4. Minus 3, so it's going to be 5. So 2, 5. So 2, 5 right there. So we got a pretty good idea what's going on over here. Let's try x equals negative 3 here. See what's going on right there. So that's going to make, come on, negative 3 squared plus 2 times negative 3 minus 3. Negative 3 squared is positive 9. 2 times negative 3 is negative 6. 9 plus negative 6 minus 3 is 0. It's negative 3, 0. It's a point right there. I now have a pretty good idea what this looks like. This curves down here somewhere, and here is going to curve back up. That's a shape called a parabola. We're not going to get carried away with parabolas in this class, but anyway. You can see that shape. Now, the point I wanted to make with this example is I put a couple of points. These first couple of points we just guessed. I mean, you gave me that one. We just guessed some points, got them on the graph, and then from there we decided what value of x do we need to know the value of y for? Where do we need points so that we can figure out what this looks like? So there was no saying, oh, we just pick these points and then figure out what it looks like from what that makes on the graph. No, we put a couple of points on there and then figure, okay, what values of x should we try to fill in the missing spots? And that's the whole thing that needs to be done with these. So what I have for you, what I'm going to give you now is a worksheet with a bunch of 10 equations on it that I want you to make tables for and graph. If you want to work together on this, you can. But it's important we have this done for Tuesday because this worksheet's where we're going to start a conversation on Tuesday.